Hello everyone, and welcome to this week's GeoTalks Express webinar. We're glad that you've chosen to join us this afternoon. Today we will be discussing and going through a workflow in Global Mapper, conducting a suitability analysis for viticulture. My name is Mackenzie Mills. I'm a technical writer at Blue Marble, and I'm joined today by Senior Application Specialist Billy Noble. How are you today, Billy?
Doing great, Mackenzie. How are you?
I am doing well. So let's go over a few notes about the webinar and some upcoming events before we dive into our suitability analysis today. First off, we are using the GoToWebinar program to get this webinar live to you today. With that format, hopefully you can hear us, but attendees are in listen-only mode, so unfortunately we can't hear you if you speak. If you do have any questions about the workflow steps that we're going through, about Global Mapper, about what you're seeing on screen as we go through some content today, please drop a question into the questions panel that you should see as part of the GoToWebinar toolbar setup that you have on screen. We'll keep an eye on those questions during this live broadcast, answer some as we see them, and for any questions we don't get to answer live, we'll follow up via email. This session is also being recorded, so there will be a recording of this webinar available on YouTube for you to review, or maybe you are watching the recorded version right now. So into some upcoming events.
So to start, this is our last GeoTalks Express webinar of 2021. And to begin 2022, Blue Marble GeoTalks 2022 will be held on Wednesday, January 26th from 9 a.m. to 3 p.m. US Eastern Time. So take note, Eastern Time. GeoTalks is a free day-long conference that offers a mix of company news, product development updates, some tip and tricks given by some of our experts on staff, and most importantly, a range of engaging presenters who will share their experiences in their industries using Blue Marble software offerings. So some of the speakers we have listed here, Larry Meyer, PhD, Director of the Center for Coastal and Ocean Mapping at the University of New Hampshire. We'll talk about his latest expedition to the Arctic and how he uses Global Mapper in his seafloor mapping work. We have Brett Rhodes, a mine surveyor based in Australia, will walk through a Global Mapper terrain analysis project focusing on high-risk mining pits. And from across the pond, we have Paul Seaman, a geophysicist based in the United Kingdom, and we'll share how he uses Global Mapper in the study of submarine columns with the potential for rapid carbon sequestration in the Ika Fjord in Greenland. So don't want to miss that. The registration is now open, and you can go to our website, bluemarblegeo.com/geotalks-2022. And also to note, some of our upcoming trainings. We've finished our training sessions for 2021. We're now looking ahead to 2022. So if you want to stay up to date on Global Mapper and also Geographic Calculator, you can attend one of our training sessions. So starting January 10th through the 14th, we will be doing our Global Mapper public training class. The next week, January 18th through the 20th, we'll also be using Global Mapper, but focusing on LiDAR processing. And then February 8th through the 10th, we will be doing a geodesy and geographic calculator training as well. So if this kind of training is something that has had your interest for some time, we encourage you to sign up for this one, as these are less frequent than our Global Mapper public training classes. So for more information, you can visit the website listed here as well, bluemarblegeo.com/GIS-training.
So one last announcement we have before we dive in, we have the Blue Marble Academic Scholarship for the year 2021-22. This is a scholarship hosted by Blue Marble, and it's open to any undergraduate or graduate students. Participants may submit a written thesis, project report, poster, any project demonstrating their use of GIS in their education and learning. One lucky student will be selected as the winner and receive a $500 scholarship and a copy of the Global Mapper Pro program. The deadline is fast approaching for this scholarship opportunity for this year. The deadline for submissions is November 30th, so right at the end of this month. We already have some great submissions, but if you are a student, if you're interested in this opportunity, we highly encourage you to reach out and submit to this scholarship opportunity. More information on this can be found on our website as well. So with that, let's dive into some viticulture suitability, the content of today's session. As I said, we'll be using Global Mapper to conduct this suitability analysis. And maybe the first question you have is, what is viticulture? So for those of you who don't know, viticulture is the cultivation of grapes for the making of wine. This usually occurs right near a vineyard or winery where the wine is actually made, especially when folks have a focus on that locally made wine. Some conditions that we want to consider when conducting the suitability analysis for viticulture. We have some terrain considerations and then some soil and climate considerations as well. We want to make sure that we're picking a location that will give us a good grape crop so that we can make lots of wine. As far as terrain goes, we're looking for hillsides on which to grow our grapes. So you'll commonly see pictures of, sweeping hillsides with grape crops on them, the classic vineyard scene. But it's actually a practical use as well. Hillsides increase drainage for the crops, so you don't have to worry about root rot or rot of the plants themselves, which can be a risk to wine or grape crops. In addition to considering just the general slope, the hillside nature of the terrain, we want to consider the direction that slope faces. We're going to be looking at an area in upstate New York, so in the northern hemisphere, and we want to really find a south-facing slope, something generally southern facing. This will increase sunlight, increase warmth to our crops, and sort of extend that growing season to the maximum amount of time available, so that we can produce the best crop possible from this land. As I said, we also want to consider soil type. So, for viticulture, for growing these grape crops, you want to make sure that the soil is not too rich in nutrients and it's not too dense and compacted. We're going to be specifically looking for some loamy blend soils, so a blended soil type that will, support these crops well. And lastly, we do want to consider the climate, the average temperatures in the area. And to do that, we're going to be looking at plant hardiness zones. Plant hardiness zones are something produced by the U.S. Department of Agriculture to basically break the area, the land area, up into different categories based on annual average temperatures. It gives you a little insight into what maybe varieties of crops or varieties of grapes in this case will do well in which areas, giving a little guidance there depending on what grapes you want to grow or what grapes you can grow easily in this region. So to conduct this analysis in Global Mapper, we're going to use a variety of tools from the program. We're going to start out with some raster reclassification. So this is a tool that allows you to take a raster layer, be that imagery or a pixel-based elevation data, and reclassify it based on the pixel values in that data and some user input rules. We're going to stick with a little bit more raster processing and jump into raster calculation from there. So bringing multiple raster layers together, applying a mathematical formula in order to derive some new information and create a new layer in Global Mapper. We're then going to move from that raster-based data into some vector data with a vectorization process. So this is taking a raster layer of data and turning it into some vector data, some vector areas. With the vector data comes the opportunity to add and manage attributes. So we're going to be doing some of this as well as we work with that vectorized data. We're going to be adding attributes, searching attributes, and managing them so we can, really explore what data we have, what characteristics are there a little bit further. Lastly, continuing with vector data, we're going to do a little more analysis with the spatial operations tool. This is an analysis tool that allows us to analyze and create new data layers based on the spatial intersections and relationships between existing vector features in a workspace. So with that, I'm going to actually jump into the Global Mapper program and start looking at the data that we have to kick off this suitability analysis. So first off, just a little intro to the region that we will be working in today. This is a town in upstate New York, as I said, in the Northern Hemisphere. I've got some imagery loaded in here. Just as a reference, we can see that there's a waterway, a lake, I believe, coming down one side of our study area. And the black outline that we have displayed as well is a vector feature describing the town bounds. So this is a particular town in this region where we're looking to maybe open a vineyard, grow some grapes. And we want to find the suitable areas within this particular town. So to start with our first suitability requirements here, we're going to do some terrain analysis. And for that, I have a terrain grid layer loaded into the workspace. I can turn that on in the control center, and I'll turn off my town boundary and even the imagery in the background. So we're just looking at this terrain layer. And it's shaded by elevation. Now we can see the change in elevation based on the colors being shown with this data. We can see that the texture of the land, of the terrain, with the lighting that has been applied with hill shade in Global Mapper. But remember, our first suitability criteria is slope. So we want to analyze the slope of the terrain in this region. To do that, to view those slope values and begin working with them, I'm going to change the terrain shader from this little drop-down menu at the top of my screen. I'm going to enable the slope shader here. So now instead of showing our terrain grid by elevation, we're seeing it colored by slope, where our lighter areas are a zero slope or flat areas, and it gets darker in our gradient as the land gets steeper. And this is done in Global Mapper by comparing those small neighborhoods of pixels, comparing each pixel to its neighbor in order to determine the slope. Now, to bring us to our first analysis method here, we're going to bring up the raster reclassification tool. I'm going to leave that slope shader applied, and from the analysis menu, bring up raster reclassification, and Global Mapper will work through and pull all of these slope values into a histogram so that we can reclassify them. So as I said before, when I was introducing this tool, this is something that can be done with the terrain data like we are doing now. It can also be done with imagery data, whether that's RGB imagery or a palette-based image. It's really useful for any raster data type that you may encounter and you may want to analyze further. So it's a great tool for that type of analysis. As our histogram builds, we'll talk about the slopes that we're interested in. As I mentioned at the beginning, we want to consider hillsides as our prime areas for growing grapes. So for that, we are going to choose hillsides that have a 3 to 6 degree slope value as our first choice areas for our grape cultivation. Now with the raster reclassification tool on the left side, we have these slope values depicted in our histogram. We have our layer name at the top of the right side. We're going to name our new layer, our reclassified layer, reclassified slope. And then below that, we have the opportunity to enter our raster reclassification rules. So these are going to be some rules based on certain input values. We're going to assign an output index. So our Gentle hillsides, values 3 to 6 in slope, will be assigned output index 1 because those are our first choice areas. We can add a description here as well and assign a color that these pixels will be shown with when this new layer is created. So here we are creating a palette image as an output. So we're moving from this 3D terrain to an image that discretely categorizes the terrain in this area. And the value of each pixel that has a slope 3 to 6 in our source data, our terrain grid here, will have an output index value of 1 and will be shown in this light green color. Our second choice class for our slope areas is going to be slopes 1 to 3, so slightly flatter areas. We don't really want to go too much steeper than 6 degrees. It makes the land a little harder to work, harder to get farm equipment up there. But we'll go a little flatter for our second choice slope, and that will be output index 2. Add a description and a color here as well. We'll use a slightly darker green. And then our third choice areas are going to be those flat areas. You can definitely farm these grapes on a flatter area. You just want to keep an eye on drainage there. So we'll make that our third choice. Again, adding our values, our output index, our description, and our color, make it a darker green. Now, these first 3 rules take care of all of these slope values in our terrain grid from 0 up to 6 degrees in slope. But looking at the histogram, we can see that there's values above that. So to take care of those, include those in our reclassification. I'm going to add a 4th rule here that takes everything else and just assigns it a no data value, basically forgets it. We're not interested in those steeper areas for this particular analysis, so we don't need to include them in our output layer. Now with our 4 rules entered here, I'm going to click validate at the bottom to make sure that these look correct. Global Mapper recognizes them as correct, and we will indeed get an output image from this. And then we can click OK to process. Here, Global Mapper prompts if you want to save your raster reclassification definition. I'm going to choose no in this case, but what that saving of a raster reclassification definition does is just saves a small .gmr file with those rules that we just created, so that if you were to run this analysis again, maybe on a different terrain area, maybe you're just duplicating this process, you can easily load those rules directly into the raster reclassification tool without having to manually type them in and select the colors and all that again, just streamlining your workflow a little bit there. So as that process completes, we have our new layer in the workspace, reclassified slope. I can turn off the terrain in the background and we see that we have our 3 shades of green representing our 3 classes, dark green for our flat areas like this, lake area we're seeing on the left side. Obviously, we don't want to grow our grapes there, but we'll take care of that a little bit later in the workflow. And then we have, our light green areas, our most ideal slopes, and moving through medium to dark green for our flatter areas. So the next terrain condition that we wanted to consider, if you think back to that brief outline of our suitability criteria, we want to consider slope direction. So for this, I'll turn off my reclassified slope layer, bring back the terrain grid, and instead of looking at just the slope values in degrees, we want to look at the aspect or the slope direction. Global Mapper has a built-in shader for this one as well. We've got the slope direction shader, which, as you can see, shows the aspect or which way every pixel in this data set is facing. And we're going to use this for our slope direction analysis. Again, we're going to use a similar process to the slope analysis. We're going to bring up the raster reclassification tool, but this time, since we have the slope direction shader applied, those are going to be the values that will be considered that we can use for our raster reclassification. Now we want to look for our southern facing slopes since we're in the northern hemisphere. So southeast, southwest, and straight south facing slopes. Our southeast facing slopes are actually going to be our first choice for our suitability criteria. We want to have southeast facing slopes. That'll give our crops a little bit more morning sunlight, and that'll help dry the dew off them quicker and just give them a little more health that way. Our second choice is going to be southwest facing slopes, so a little more afternoon sun. And then our third choice in slope direction is going to be our straight south facing slopes. So instead of typing in these values again to manually create our rules, I have a raster reclassification definition saved, and I can load that from a file here. Bringing that in, we see our 3 rules and our 4th else no data to take care of the rest of the data, our northern facing slopes. And we see southeast is our first choice, southwest our second, and then south our third, and the colors associated with those values. So running this will create a new layer in the workspace as well, and that will be a reclassified slope layer. So here we have that, again, turning off the terrain grid in the background. We see our reclassified slope layer, another palette image layer with our 3 colors represented. And if I display the reclassified slope and reclassified slope direction layers together, we can start to visually see where these different terrain areas that satisfy the different criteria overlap. I can actually take my slope direction layer, open the raster options for it, make it a little bit transparent so we can start to see where the green slope areas, shine through from the background there. Instead of leaving this just as a visual analysis and trying to pick out our ideal locations from this, we're going to use the raster calculator to more intelligently combine these 2 sets of criteria here. So from the analysis menu with my 2 palette layers enabled, I'm going to bring up the raster calculator. And here we can combine these layers. I'll give my new layer a name. Combine slope and direction will be the layer that we're creating with this tool. And we're going to use a custom formula to multiply our reclassified slope and reclassified slope direction layers together. So our simple formula is just going to be B1 times B2 to bring these 2 layers together. B1 and B2 here are just placeholder, variables essentially. We will have the opportunity to choose where those values are being pulled from in just a moment. We can go ahead and add that custom formula as a single band for our output layer. And with that band added, click OK, and we'll be prompted to select the bands, band 1 and band 2, as represented in our formula. Now, since our reclassified layers are both single band palette layers, we just need to make sure that one of them is selected as band 1 and the second as selected as band 2. The order in this case, since we're multiplying them together, doesn't really matter. So I've got slope as band 1 and slope direction as band 2, and I'll click OK to begin applying that formula, and Global Mapper is going to do this multiplication on a pixel by pixel basis in order to come up with our new layer in the workspace. So while this processes, let's take a look at a little table that describes, what this formula is really going to give us in terms of an output layer. So here we have it. We're calculating a terrain suitability score essentially here. We've got our 2 layers, our slope layer with our shades of green, our hillsides value 1, low slope and flat areas. We next have our south or aspect or slope direction values, southeast, southwest, and south. And by multiplying those values together, we're going to get a series of numbers here. Any place that has no data is going to have a value of 0, and so the output value will be 0 We don't need to include that in this table, but looking at the values that we will get, we'll get values essentially 1 through 9, where the lower values meet our sort of top criteria or our top choices for slope and slope direction here. We're looking for areas that mostly satisfy at least one of our top choices. Value 1 will obviously be the best, but we're going to take into consideration values 1 through 4. So the ones I've just highlighted here, where some of our top criteria is being met. If we can avoid it, we'd like to avoid just our third choice criteria being met here. Popping back into Global Mapper, we can see that we have calculated our new raster layer, our combined slope and direction layer in the workspace, and we can turn off our reclassification layers. I will change the shader so that we can see the values represented in this new calculated layer. So here we have values 1 through 9 represented, just like we saw on that table. We've got plenty of holes in this data set where there was no data, where our slope and slope direction areas did not overlap. But again, we're looking to really highlight values 1 through 4 from this data set. To show that visually, I can apply a custom shader to this data. I have a wine shader that I created right in Global Mapper in the configuration settings, and this does a good job highlighting those values 1 through 4 that we're interested in. Another way we can crop down the data that we're actually viewing here is by altering the elevation values in our combined slope and direction layer options. So you might note we're applying an elevation shader, we're altering our elevation values to change the visualization of this data. Well, this is being interpreted as elevation values, to be drawn and represented and allow us to, dynamically change the visualization here in Global Mapper. We're not actually seeing, terrain elevation values as you would commonly think in this layer. These are our terrain suitability scores, because remember, they're derived from those reclassified layers where we gave each of those, general classes a number, a value, and then we calculated from there. So we're looking at our terrain suitability scores here. We've got a nice map of the suitable terrain areas within this town where we might consider opening our vineyard and growing our grapes. As a last step here, we're going to go ahead and move into some vector data. So we're going to take this raster combined slope and direction layer that we have and convert it into vector data. To do that, I'm going to go up to the layer menu and choose to create area features from equal values using that combined slope and direction layer. And here in this dialog, we will choose to create areas for all of our encountered elevation values, although we know those are really terrain suitability scores. And what this tool will do will be create polygons bounding those groups of pixels that have the same value. So we'll have polygons for, the suitable areas with the score of 1, score of 2, 3, and 4. Since we have cropped out the higher number values in this layer by altering the elevation options in our layer options, we're only going to work with Global Mapper's only going to analyze and create area features for our displayed data values. So that would be values 1 through 4. Those are the ones we want to consider. And so that's what we're going to work with here. That process will create this vector layer. So here we have the vectorized version of the same information. The colors are transferred over from our shader that was applied, that custom shader, and we have our different values. Now, this is data that's derived from pixels, so they are a little bit jagged on the edges in some spots. And we also have some very small areas where the two, reclassified layers barely overlaps to give us a suitable area. Some of those really small areas, they're not even big enough to consider grape cultivation. So we'll want to remove those from consideration, but we'll do that at a later step in this process. For now, we can take the feature info tool and click on any of our area features to confirm that they are vector features. We get the feature information dialog, and we see here we have one attribute that was pulled from our raster calculated layer. It is called elevation because that's how Global Mapper was interpreting it, but we know from our workflow and process that this is actually our terrain suitability score. And so to make that clear, I'm going to open the attribute editor for this layer in order just to rename this attribute. With a right click, I can easily rename this terrain suitability score. That will update, and now we have that meaningful attribute value attached to all of our features. Now at this point, we've completed the terrain, that slope, and aspect analysis part of our workflow. So maybe that's my area of expertise. I'm now ready to share this data with another user of Global Mapper, another colleague who will take the analysis further. And to do that, I can export this single layer to any supported vector format from Global Mapper. But I can also package up all the displayed layers in my workspace using the export option to export Global Mapper package file. This creates a single .gmp file that I can share with another Global Mapper user. They can then open all of the layers that are displayed in their version of Global Mapper and just continue right from where we left off now. And that's exactly what we're going to do. At this point, I'm going to transfer the screen over to Billy, and he's going to continue this analysis considering some other characteristics of this region.
All right, so now that the terrain analysis part of our viticulture analysis is finished, now I can take a look at some of the other parts of this workflow that are needed to find suitable sites. And so that is finding the correct soil type, and then also at the end, finding out the correct polygons that have the right acreage or square kilometers, as we'll be doing in this workflow for the actual vineyard sites. So this first layer that I'm going to operate on is a soil layer. So if I turn off the vector layer that Mackenzie created, you'll see this polygon. There's a bunch of polygons in this layer. So if I use the feature info tool to select one of these polygons, I can see that the feature has a symbol. So it's a map unit symbol. So if I already have a external document that has the symbol meanings, because it's easier to search specifically the soil types that we need. So as Mackenzie mentioned before, now the suitable soil types is a silty clay loam, sandy loam type of soil. So what I'm first gonna do is add those descriptions to this layer in the control center by joining a file. So if I right click on the soil layer, go to edit attributes and click join attributes at the top. I can choose the file that I want to join. So I have the CSV file, actually text file here, that contains the information about each of the codes. So if I click open, at the bottom you can see a preview of this file that I am trying to join with my my features here. See, there's map unit symbols and also map unit names. I already see that there's silt loam here. Some of these are going to be the polygons that I'm going to identify for the suitable site analysis. So to copy these map unit names over to the file, I simply join based on a similar attribute type. So I can see here in the external file, map unit symbol, and in the layer that's open in the attribute editor currently is MUSYM. So those have matching attributes. So if I click OK here, all these features should have been updated to now include a map unit name. So if I just click on one of these polygons again with the feature info tool, there's a new attribute here called map unit name with that information containing what that map unit name is. So now that that information is in the layer, I can do a vector search and build a query to identify the polygons that have the suitable soil types that I need. To do this, I just go back to the layer. I can right click, go to edit attributes again, and go to the search button here at the top left of the attribute editor. And it pulls up the search vector data window. So feature types that I'm searching on doesn't really matter here. I'm doing area features and it's to a specific layer. If I had all layers enabled, any attribute available would be listed in this query builder that I'm going to use. So I could go ahead and build a query to find map unit names that are like, and as I mentioned before, silty clay loam or sandy loam, so I have to do that twice. If someone had already done this project, I can load a saved query that actually has the query built in, or I can copy and paste from whatever document I have it in. So if I copy and paste, the query builds right here. Map unit name like silty clay loam, map unit name like sandy loam. Note that there are asterisks on each side because these are wildcards. So it'll identify any attributes with sandy loam in it with words on either side of silty clay loam or sandy loam. So I can validate this query. So this is a valid query that will find features, hopefully, in my soil layer. So if I click search, now I have broken this down a little bit more. So I can select all the features in this layer using this button here at the top called select all. So with the digitizer now, these are the sites with the suitable soil for the vineyard. So what I want to do now is actually take these features and cut them into their own layer. So what I can do now that they're selected, I can click Control C on my keyboard, or I can go to Edit and copy selected features to clipboard, and just use Control V and paste these selected features into a new layer. So I can call these suitable soils. And now they're cut into their own layer, or pasted into their new layers, excuse me. So if I turn off my original soil layer, I'm just left with some of the polygons that are identified as suitable soil types. So I'm only focused on here. To style these, so to give them some color, so you can actually identify them a little bit easier, I could go to right click on the layer and go to options, area styles, and I can apply styling of each of the features based on an attribute. And it probably makes sense to do the symbol. If I click load values, initiates a coloring process for the features on each attribute. So I could choose maybe a green color and maybe make it transparent so I can see the imagery underneath. Clicking OK. In choosing to assign each of the map symbols for a random color. So they're not all going to be relevant, but they're going to be listed here now. Click apply, and now you have your colored polygons based on a the category of the map symbol or soil symbol that was being used. So now that I have my suitable soils, now I can do an analysis to find the overlap or areas where the combined slope and direction areas or the suitable terrain types intersect with my soils. And you can already see that, if I zoom in here, you can see that my suitable soils layer that I extracted overlaps some of the areas where there's suitable terrain. To isolate this even further, we can use this tool called Spatial Operations, which is in Global Mapper Pro. So the Spatial Operations tool allows you to conduct analysis on vector layers in Global Mapper. So there's various amounts of spatial operations you can choose. What we want is intersection. So any layer that overlaps a region with another layer will create a new layer. So to demonstrate this, this new layer that I want to create is going to be called Suitable Vineyard Sites. So layer one, I'm just going to make the combined slope direction areas, the one Mackenzie made, which is the suitable terrain. Layer two, suitable soils. These are just area features, so I'm not going to change any of these things. If I click run, you'll see some warnings here about invalid geometries. Don't mind that. It doesn't really matter in this case because of the area features are still going to overlap, and it will create area features correctly here. All right, so now that has finished, I can close the Spatial Operations tool. I can turn off my combined slope and direction areas and the suitable soils layer. Now I'm left with a layer that takes into account sites that have suitable terrain and suitable soil. So I'm pretty much almost there now with identifying prime sites for our vineyards to grow grapes. One of the second to last things to do is actually apply measurement values to find the actual surface area of these polygons. As Mackenzie mentioned, there's a 5-acre, minimum for making commercial grape production. So I have my terrain layer turned on underneath my imagery, which I need to do to be able to do applying terrain calculations to my features. So if I use my digitizer tool right now and select all the features here, so I can right click on my suitable vineyard sites layer, select all, click OK, and then right click in the workspace and go to analysis measurement, calculate elevation slope stats for selected features. This is a warning letting me know that it will create points at min and max values. I want to click no. I don't want those new features there. After clicking OK, I'm told that it's applied these new attributes to each of the features. So if I go ahead and use a feature info tool, we can see some more information about these polygons. So listed now here, we have minimum elevation, maximum elevation. Most important thing that what we want to do when querying, again, for suitable polygons is looking at surface area 3D. Now there is an option here if you want to keep going and digitize and clean up these polygons a little bit and combine them. You can go ahead and do that. But for this, what we want to do now is copy a couple more attributes um, to the features. But first, what I want to do, as I just mentioned, is isolate areas that have a size greater than 5 acres. So as you remember from earlier, I showed you how to search for attributes. Right-click on the attribute editor here, edit attributes in the control center, and click the search button. So that new attribute that has been built into the layer called Surface Area 3D Searchable, I want a search for features that are larger than 5 acres. Since this operation was done metric, I have to convert that to square kilometers. So greater than or equal to 0.02. And I want to validate this query. It's all set to go. So I click search, and it cuts down to a couple more polygons that are suitable. So I could select all these features again, and then copy and paste to a new layer. And I could call these maybe the vineyard sites that I want. So if I turn off my old suitable vineyard sites layer, these are the areas that are larger or large enough for commercial production. There is one more attribute that I want to embed into these polygons. And as Mackenzie mentioned earlier, taking into account USDA hardiness zones, that's what this layer I just turned on is. You can see that there's 2 different colored polygons here. These are sites or zones that are suitable for grape making. And both of these zones, as I just said, works for grape making, but maybe the tolerance for grapes are different for each zone. So if I just select on one of these using the feature info tool, you can see that there's a grid zone ID, zone 5B, and this value of -15 to -10 Fahrenheit, which I've learned is the value of the average annual extreme minimum temperature that could reach in these areas. So maybe these values have some influence on the zone type, just looking on the imagery and some of the terrain. So these are 2 different zones, but you can grow grapes in both. So to copy that attribute that I was just talking about, what I can do is select the vineyard sites using the select all option by right-clicking on the layer control center, and right-clicking again in the workspace. This is an attribute function, so attribute style functions copy attributes between or overlapping features. Because these features do overlap the hardiness grid zone. So I'm not really interested in all of these attributes to copy over. I'm mostly concerned about zone. So the loaded features I am copying from, and I'm copying that zone attribute to the selected area features. For multiple feature handling, because I want to make sure I keep those attributes from each matching from feature. And click OK. There's an option for how you decide which of the zone attributes you want to copy over. So any overlap with a selected feature is allowed. And what you're going to see is that actually the attribute from both of the features, if they're overlapping, like I can kind of see over on the right here, it will be embedded in the feature. So let me deselect these features and then use the feature info tool again and select this polygon. If I look to the bottom, you can see that both of the zone values are now embedded in this feature. So now you have finished up your analysis of looking for the suitable sites in this town of Middlesex, New York. So now you do have options to export this file. I can send it back to Mackenzie and export it to a different vector layer. Is there anything else, Mackenzie, I'm missing from this analysis now that I have these polygons?
No, I think that's a great start for our suitability analysis. I mean, we've done a lot of work in Global Mapper. We've taken this, publicly available terrain layer in order to analyze the terrain of the area, and then a couple layers from the USDA, the National Soil Surveys layer for the soil types and the plant hardiness zones in order to create some small features that identify key areas in this town where we might want to start or open our vineyard. Next steps, as Billy said, you can absolutely export this data to any supported file format, create a PDF map to share with someone of these possible sites, or even transfer this data to the Global Mapper mobile application, have it on your phone or a mobile device to take out into the field as you maybe go to visit these sites, get a better lay of the land visiting them in person. So there's a lot of options you can, take from this point, but it's a pretty comprehensive suitability analysis that we just conducted. And with that, as we come to the end of our time here, I just want to thank everyone for joining us along this journey, along this analysis. I hope that maybe you learned something about a new way that you can use Global Mapper for what you do and your work. If you do have any questions about the workflow we completed today, the suitability analysis or Global Mapper in general, please reach out to us. We're happy to answer any questions you have. We have 2 emails on screen, orders@bluemarblegeo.com for sales and licensing issues, and then geohelp@bluemarblegeo.com, where we have a team of application specialists ready and willing to answer whatever questions you have about Global Mapper or any of the Blue Marble products. So thank you for joining us today, and I hope you all have a wonderful afternoon.